All right, we're live. Another episode of Monero Talk. We're with Benedikt Bunz, one of the one of the authors of Bulletproofs, or how is it explained in the community?
That's true, yeah.
Okay, and you were among who were the other authors?
So it was I was the first author, sort of. So then it was Jonathan Boodle from University College London, my advisor Dan Benet, and then also the Bitcoin core developers Peter Woolley, Andrew Poelstra, and Greg Maxwell.
Cool. Yeah. So anybody that's not living under a rock in the crypto community is well aware of Bulletproofs, I think, as of today, now that it's launched live on the Monero network.
Yeah, it's a very, very timely podcast. Like we didn't schedule it like this, or at least I wasn't aware that it was going to.
We were aware. We knew the 18th was the day of the hard fork. So
yeah, too much. By the way, I'm just maybe going to get headphones so that.
Okay.
But yeah, just 1 second. Hey, can you hear me? Can you hear me? Test.
Oh, no? Can't hear you.
Test 1, 2, 3.
Yep, I'm hearing you now. Okay.
Perfect.
Yeah, so we knew the hard fork. Yeah, hard fork was happening today, and everybody's been waiting for Bulletproofs to be added. So are you working closely with the Monero community, or not so much? You're just kind of on a different level there, just kind of more working behind the scenes on the cryptography itself, and not so much interacting with the Monero community.
I mean, more sort of, working in the academic community. Like, I've talked to the Monero folks, and I guess I did an audit of the code. But no, I mean, that's the cool thing, about research is we released everything to the public domain, and we had some code that we made publicly available such that anybody can take it and use it. And that's exactly what sort of the Monero team did, is they just took the ideas and implemented this themselves and used it. And I think it's a great thing, if we don't hide the secrets, but, like keep everything in the open and keep everything accessible. And that's the value of research.
Is it fair to say it was originally designed with Bitcoin in mind, or not even so much?
Not, I mean, it's, so the Bitcoin core developers came to us, actually, I think, we were originally talking about Mimblewimble, which is another, like an idea concept for cryptocurrency where you have confidential payments. And I think it was designed with confidential payments in mind. And in my opinion, like, so that's something that is separate or important, like very much independent of what cryptocurrency you have or you use, right? I think that no matter what your views on privacy are, like even if you look at something like Venmo, which is something that people use in the real world, in the US at least, which is like you can just send money privately. Even there, in the most public version of it, you see what, who pays whom. And, this might be scary for some people, but even in that version, you don't see how much is being paid, right? Even there, the amounts are hidden. And I think this is sort of, I would never want to have, like, I don't think, even if you're a business or if you're a private person, you don't want to have your salary public on the blockchain. You don't want to have, if you're a business, you don't want to have your business secrets, how much you're paying for, your supplies public on a blockchain. So I think it's really just about, like, I think confidentiality is really just about making blockchains usable, more than anything else. And then there's the additional aspect that I think, like cryptocurrencies like Monero or Zcash have, where you also want to hide who's paying whom, which I think there's also very good motivations for. But that becomes in some ways, more of a political discussion also, what you want there. I certainly think those are very important features as well, but I think they're sort of like almost orthogonal. So it wasn't really in mind with, a particular cryptocurrency. I think it's just something, that like this, like zero knowledge proofs are some a very general cryptographic tools, and I think confidential payments are something that are like, I hope whatever the future is going to be, like, whatever cryptocurrencies exist, my hope would be that all of them have some way of, at the very least, some way of privacy, and at the very least, confidential transactions, and hopefully even more, and so. But it's great that Monero is taking this step forward and implementing it and using it, and I think that's really cool and amazing.
Yeah, I mean, that must be exciting to actually see your research be implemented. I mean, what was it, only a year ago that you guys finished the paper?
Yeah, we published the paper less than a year ago. I should look up what the date was that we first put it online. I mean, I can actually do that right now. But that's, obviously I'm super excited about this. Yeah, November 1st, 2017. So less than a year ago.
That's amazing.
Put up the paper, and within a year, it's like securing, I don't know, over $1 billion worth of Monero. That's exciting, slightly scary, and but it's just, that's one of the amazing things about this hype is the willingness to take new research and like really stay cutting edge research and deploy it and use it in practice. And we've had like zero knowledge proofs are a really old thing in cryptography, but before cryptocurrencies, no one was really using them, and we didn't have use cases. We only used sort of, cryptography is used, like signatures and encryption is used all over the place, but sort of the fancier, newer cryptography has only become, I guess used and applied and with these cryptocurrencies and in a wide scale. There's some electronic voting before maybe, but I think that's that is one of the things that is really exciting about this.
So is it fair to say that you guys are, people in your field are potentially becoming more excited about something like Monero then, because it's actually implementing these technologies?
Yeah, I think so. I mean, I can't speak for the whole field of academics or whatever. I think in general, I think that cryptographers have come, in the beginning, maybe people were slightly dismissive, or there's still people see all the hype, see all the the shit coins, and see all the pump and dump and whatever, and the crazy volatility, and it's very easy to dismiss cryptocurrencies if you're not sort of in the middle of it.
Mm-hmm.
And for like some of it for pretty good reasons. It's there's a lot of craziness going on, and I think it's important to admit that. But I think people are realizing now that there's some like underlying value in it, and that there's actually cool technology to be used, and cryptographers especially are realizing that there's really cool, interesting open problems, really, people willing to read your research, really people getting excited about your research. Like, normally you publish a paper, I guess, and 3 people read it, and like that includes yourself. And there's this like, and here, you get communities excited about your research, and that's something I guess researchers thrive on, as most humans thrive on acknowledgement and recognition. So I mean, I think this is something really exciting, and I think Monero being willing to take new research ideas and develop them and have a fund research, and I think all of these things make it sort of something that is seen as more reputable, and something where you wouldn't, like, no one is going to like accept the paper where you solve some problem for a cryptocurrency that no one cares about. So I think like it's important to have that be recognized as something reputable, and I think that Monero certainly is there.
So what do you, I mean, I don't know if you want to talk about this, but are there particular coins that you're excited about? Is it Monero and Bitcoin? Is it like the big, and like a Zcash?
I'm very
Or you're agnostic?
I'm pretty agnostic. I'm advising some cryptocurrency startups. I'm like, I try to be as agnostic as possible. If people are solving interesting problems, doing something new, not just copying old stuff, I think then that's interesting. I don't have I try to stay out of the political arguments as much as possible. I don't think that my voice adds much there. That's for other people to discuss. And as long as there's like certainly coins. I don't know if there's certainly coins that I would kind of dismiss. Like there's I don't know, IOTA had this thing where someone found a break in the hash function, or like some researchers found like a problem, a security bug with it, and then instead of sort of acknowledging that and fixing it and then saying like thank you for they did the researchers then disclosed it to the team such that the team could fix it and no one would get harmed. And instead of doing that, they basically publicly sort of shamed the researchers and saying, that they're doing this for ulterior motives and didn't really acknowledge that they made a mistake. And I think that sort of treatment is not okay. Like that's certainly something that will get researchers to not like to dismiss a currency. So I can say that I'm not a fan of IOTA, but other than that, I try to stay sort of out of the politics. And I think, in general, I think that privacy is something that I'm personally excited about. So, Monero or Zcash or the Mimblewimble protocol are interesting things. But yeah.
Do you also look at it in terms of fungibility, and as fungibility being an essential component to these things?
Yeah, I think that I view it from multiple perspectives. I think that fungibility seems to be important. It's like there's always the question of like Bitcoin doesn't have so great fungibility, but at least until now it works in practice. So we'll have to see how much like does this become an issue. I think that from a user perspective, I think in the end, users and usability matters the most. That's sort of, and we have to make privacy usable. Like otherwise people are not going to use it. People are very, very lazy about using privacy if they don't absolutely need it. So we need to make it sort of very much the default, very user-friendly. So for example, the problem is if only the people that need privacy use it, then you get terrible privacy, right? Because then everybody that uses Monero or a privacy coin is immediately suspect because they need privacy, right? So like I don't like the notion of just privacy coins is it's sort of sad. Like every coin should be like the default, and then it becomes a much more powerful tool. Right. It's that's the great thing, I guess, with sort of a completely different field, but end-to-end encryption in messengers, like WhatsApp deploying end-to-end encryption to billions of users around the world. It's like end-to-end encryption has become effectively the default for messaging, which is really cool because now suddenly if you use an end-to-end encrypted messenger, you're not suddenly suspect anymore because you want to, like, you're not willing to say what you're texting to your friends. You don't want to put that publicly, but it's become sort of accepted that that's the default. And I think if we can achieve the same for currency, that would be a goal that I'm personally invested in and strive forward. And I think, for example, like the thing that I've been saying about confidentiality, I think that, we need to make it clear to users that that sort of like revealing everything publicly on the blockchain is just like, it's just not usable. Like, I don't want to have my salary. I don't want to have, all of my payments publicly on the blockchain. And people say, there's this, I guess this myth that Bitcoin itself is private, but there's been lots of analysis that shows that you can actually link Bitcoin addresses together very well. You can figure out who owns, or like, which addresses go together, who owns what. And yeah, that makes it, I think, quite dangerous. And so yeah, that's certainly something that I'm invested in, and a big fan of is more privacy for cryptocurrencies. And I think there's different approaches, and I think it's honestly, like it's good that different approaches get explored, and we'll see sort of, what comes up on top.
Do you think Bitcoin will adopt bulletproofs or some form of confidential transactions?
I don't know. I'm like you'll have to ask other people for that. I think like the version that I've heard the most like reasonable approach for it is that they will have a sort of extension block where you can switch from Bitcoin to confidential Bitcoins, and then switch back, so that it's you can. That basically, if anything goes wrong with the confidential part of it, the normal Bitcoin or the non-confidential Bitcoin are not affected. And I can see that happening, but Bitcoin, for better or for worse, is like one of the more conservative cryptocurrencies. I guess it's like established itself as that, and is sort of much more conservative with adapting change. Which has the benefit that it's less likely that things sort of break. But I think it's also exciting that there's other cryptocurrencies out there that are more willing to adopt new technologies faster and whatever. But like what happens with Bitcoin, I honestly don't know. That's
right. Yeah, because that gets back to the problem that you're talking about, because then it's people are then opting into the privacy, and it's not privacy by default.
And then exactly.
It's like, well, you must have something to hide if you're deciding to use the privacy feature, as opposed to being the default function. But I see what you're saying, that Monero is privacy by default, but then the argument becomes, well, if you're using Monero at all, then you must have something to hide.
Unfortunately, I think that's that's the case. I mean, I think that if I'm, but maybe also Monero becomes more popular and more usable and whatever, and then these issues go away and people use it for other reasons, or it becomes sort of a more default thing. But it's we will see where this whole thing ends up.
Still early days. So
yeah, definitely.
So Bulletproof, if you want to explain Bulletproofs a little more. So it's basically, it's a better way of doing a zero knowledge proof. Is that a fair assessment?
So I guess we should back up and say what a zero knowledge proof is. So a zero knowledge proof is a proof that a certain statement is true, but I only tell you that a statement is true. I don't tell you why it's true. So I can, for example, prove to you, that I know the solution to the New York Times crossword puzzle or whatever, but I won't give you any information about like what the words are in the puzzle. And you will be convinced that there is a solution to it and that I know the solution, but you will have no idea what the solution is. And in a very similar way, I can prove to you that transaction is correct without giving you any information about why it's correct. So, for example, I don't have to tell you how much money I'm transacting, and I don't even have to tell you like who is sending to whom. Or in Monero, it's like you specify like M UTXOs, and you say like, hey, one of them is correct. And I guess in Bulletproofs, in Monero, so Bulletproofs is a general zero knowledge tool. So you can kind of prove arbitrary statements like this. You can, whatever complex transaction format you have, you can do the proof, and it's a very, very short, the proof is very short. It's probably less than 2 kilobytes, or for the use case that Monero has, it's probably even less than 1 kilobyte. And I think previously it was probably 10 times as large. So the transactions were larger. And in Monero specifically, it's used for the so-called range proof, which basically ensures that no new money is being created, so that the money that goes into a transaction is the same amount of money that goes out. And yeah, so that's what bulletproofs are used for.
So we removed range proofs and replaced it with bulletproofs. So
bulletproofs is a type of range proof.
Oh, it is a type of range proof. So what
you just use it to, so the range proof is the statement that you're doing, like you're proving that a number is basically in a range. And you can do that. The previous range proof used something called Sigma protocols, or something like you can describe it in multiple ways. But and the new range proofs use bulletproofs, which are a lot shorter and faster to verify as well.
So how did you approach? I was just really curious. So how did you even get involved in this then? You saw this problem with the advent
so basically, yeah, it's quite. So I was starting my PhD at Stanford. So I'm a PhD student at Stanford. So, and I guess the Bitcoin developers, Peter, Andrew, and Greg, were meeting with Dan. And I happened to be, around and got pulled into the meeting sort of randomly. And they were basically saying, like for confidential transactions or for Mimblewimble, there's this problem that the range proofs are sort of too large, like if we actually replace this, this would blow up the transaction size. And sort of, is there something you can do about this? Like, is there some better protocol that you can come up with? And then we worked on it, and we used there was some previous research by Jens Groth's group in London, at University College London, and also Jonathan Boodle, who then became one of our co-authors. So they had sort of a zero knowledge proof, and then we adapted it and improved it in many ways, and used it to solve this problem, and yeah, then I guess that's sort of the story of how this got developed. Yeah.
Could it be possibly refined even further and made even more efficient?
I can't hear you right now.
Can you hear me? Hello? Hello? Nothing? Showing sound on my end. Can you hear me?
Can you? Sorry. Yeah, now I can hear you.
Okay. Yeah. Is it possible that bulletproofs can be refined even further and possibly made even more efficient?
Yeah. So I mean, I think that the ultimate goal is to have something like so there's this other proof tool which is called a snark, and which has the advantage that it's even faster to verify. So sort of no matter how complex the statement is, the verification time is like 10 milliseconds. And the problem with snarks is that they require a trusted setup. So what this means is that someone creates a proving key and a verification key in the beginning, and they have basically some secret, some toxic material. And if they don't discard it, then they can use it to create fake proofs, which in the cryptocurrency means creating money out of thin air. So I think the ultimate goal is to have something of, that has a size similar to bulletproofs or snarks, but without the trusted setup. So with bulletproofs, the proofs are short and practically, for something like a range proof, it's very efficient as well. But if you want to prove like very large, complex statements, you could prove something like the end goal is to have something where you can prove that my whole blockchain, like I give you the current head of the blockchain, or just the header of the head of the blockchain. And here's a proof I can prove to you that the whole history was aggregated, is correct. You know, all of the signatures in the history are correct. All of the you know, the proof of works are correct or whatever. And here is this short proof, you know, and which takes 10 milliseconds to verify, and you're convinced that this is the correct blockchain, even though your verification takes 10 milliseconds. So that would be amazing for sort of scalability reasons. You know, you can literally run your full node on a phone. You don't need anything more. And I believe that, you know, this is something that we can do with snarks, but it's not something that we can do with bulletproofs. So if you can get something, you know, without the trusted setup of bulletproofs, but with the verification time and even shorter proof size of snarks, then, you know, I think that's in some ways the holy grail. And so I think, you know, people are working on that. But it's also a very difficult problem. So it's not like, you know.
Right. But it's not a mathematical impossibility that you could have a non-trusted setup version that's just as efficient as a snark.
You know, the thing is that in the end of the day, the constants matter a lot. So we have something that, you know, asymptotically achieves these things. Like it's called a Stark or a CS proof. But in practice, these proofs are asymptotically, so they don't grow a lot. Basically, they have good properties, but in practice, they're you know, they are like I think 600 kilobytes or a megabyte or whatever. So that just seems too large, and so there's some problems with that. But it's, you know, it's nothing is impossible. I don't know, like I think that, yeah, we'll see. I don't know if there's something, you know, with exactly the same efficiencies as, you know, a snark without a trusted setup, but we'll yeah, I think that's what many people are working on.
Now, snarks are being used by Zcash. Is that correct?
That is correct. Yeah.
Okay. And is Starks being used?
No, I don't think it's being used yet anywhere. I think it sort of, a snark or a bulletproof, they're sort of short enough that it makes sense. You know, they're like less than, a bulletproof is like less than a kilobyte, and a snark is even shorter. So it sort of makes sense to attach a snark or bulletproofs per transaction, right? Mm-hmm. Like in Monero now, every transaction has a bulletproof attached to it. In Zcash, every transaction has a snark attached to it. And it's like short enough that makes sense. If the proof is like a megabyte or 600 kilobytes, it does not make sense at all, like, to attach that to a transaction, because, you know, your blockchain would just explode in size. But what might make sense is, you know, using a Stark for more of these aggregation purposes. You know, that you convince someone that a whole block is correct, or even the whole blockchain is correct, using a Stark. And I think there's you know, there are people that are working on you know, I think there's a company called Starkware, and there are researchers that are very actively working on that. And we currently have we were working on improvement for, you know, it comes from a very different area, but this would bring down the proof size for Starks from like something like, you know, it would reduce it to like a third of the original size, but that's, you know, that's helpful, but like isn't quite there yet. You know, if you're 200 kilobytes instead of 600 kilobytes, then that's still way too big to attach to a transaction. But, you know, maybe there's, you know, this is how research goes. You know, there's many improvements in many different areas, and you know, people try different things, and some things work out, some things don't work out, and hopefully at the end we'll end up with something good. You know, it's not, yeah, it's not often like it's not a straight, you know, shot from like, I want to have this, now I invent this, and then boom. But it's, you know, multiple small improvements by many different people over, you know, multiple years. And so we'll see.
So could bulletproofs potentially be used for these compression features as well, or no?
So
it's only snarks and stuff.
Bulletproofs can be used to compress the size, but not to compress the verification time.
Right. Okay.
So you can prove these large statements but the problem is then it takes like really, really long to check that the statement, that the proof is correct. So that doesn't really make sense in that use case. You really want something where you can just download the proof and check it and done, right? So I think that's an exciting, that would be something that's really exciting. But yeah, there's, I think there's many open questions and research directions, and yeah, I think there's a lot more to come.
What do you think of this kind of the FUD going around that coins like Monero actually require more trust in math than something like a Bitcoin that has a transparent ledger?
Yeah, so I think there's two things. So I think that the trust in math is like in some ways that just takes time and education. I think that it's of course I can see for how like a normal user who isn't a cryptographer, this is more this seems all like magic and like magic and crazy stuff, but like it actually works, and there's an academic review process. We didn't just put out like the Bulletproofs paper and said like, hey, we think this is a good way to do this. Like you have a formal mathematical proof that Bulletproofs is as secure as like ECDSA signatures, or even more secure in some ways, or Schnorr signatures, which is what is being used in Bitcoin. So if Bulletproofs is broken, then their signature scheme in Bitcoin is as broken. So like in some ways you're equally screwed, on that realm. I think the other concern is that people bring up a lot is regarding quantum computers. So the fear here is that quantum computers can break a lot of things. They can break the signatures that are used in Bitcoin. They can break bulletproofs. They can use the previous range proof that Monero used. They can break snarks. They can break all of these things. And what is, in my opinion, even like more important is they can break the whole internet. Like whenever you visit your bank website, you rely on cryptography that is essential. That is vulnerable to quantum computers. So these quantum computers seem very scary, and I think it's important to prepare ourselves for a future when they exist. But like I'm very confident that they won't just like appear out of the blue. I don't think that's not how innovation happens, and they're still very, very far away, and it's hard to predict when exactly they come, because we're terrible at making these kind of predictions. But this is like 20, 30, 40, 50, 60, 100, never in the future, right? Like it's not even clear that we will have them. There's people that, I'm not an expert in this, but there's people that strongly believe that we won't be able to do them. I think it's important to do research sort of in that area, and develop new, and my group is here at Stanford, and many cryptographers are working on quantum secure cryptography, but it's just not ready yet. It's just like, it's not efficient enough, and I think sort of doing something with Monero with quantum secure cryptography would just not be feasible, and you would have to basically, the option is like, if you're so afraid of quantum computers, then you shouldn't use cryptocurrencies at all, but then you probably shouldn't even use the internet, right? Like that's just yeah. And there's a special, so there's like, there's a special reason why people are afraid of quantum computers for things like Monero or Zcash, which is that if you can create one, like if you fake a signature, if you create a fake signature, or if you steal a private key, which is what you can do with a quantum computer in Bitcoin, then you can steal someone's money. But they would notice it. They would have evidence that it's being stolen. In Monero, what you can do is you can use quantum computers to create money out of thin air, which, because of the confidentiality, no one would be able to tell. Okay, so I think people are very scared of that, because that would mean, it's like the worst possible scenario is the silent inflation, where you have no idea, you have no idea that your money is being stolen. You just see the exchange rate dropping and dropping because people are selling, the attackers selling these coins. But to be honest, I think that Bitcoin would be equally dead if we had a quantum computer right this second. Like, it's not, it's totally not, this is a very scary attack, but like, this attacks on everything else are equally scary. But I think this thing to remind ourselves is that, the whole world relies on this, and we have no evidence like that, people are like, we're not close, right? And I don't know, innovation works in funny ways, right? Like, we've thought that we would have flying cars for like over 100 years now, right? People were able to imagine flying cars for the longest time, but that's not actually what happened. But like, no one imagined the internet like that. I don't think people really thought of that. So I think that, it's important to prepare for the future, but it's not like, you shouldn't panic.
Right. And it's I gather from what you're saying, it's not so much an issue that only obfuscated blockchains would have. It would equally apply.
Not just blockchains, like people in blockchains or cryptocurrencies are very focused on that.
Right.
But like, I don't know, like, I think it's important that our military has secure communication. It's important that, my end-to-end, my WhatsApp encryption is secure. It's important that my, bank connection is secure. Like, a whole lot of things that we need rely on these quantum computers. And like, there's also, people will say, quantum computers are scary and I guess we shouldn't work on them. But, if we prepare for them in the right way, they have amazing applications in material design and they can solve problems that we can, and maybe when they come, it will actually be a blessing rather than a curse. So yeah, I think we should fund and invest in quantum secure research, like, absolutely, but we shouldn't panic at all. The one other thing that I want to say is that the thing to be scared of much more than like the math breaking or quantum computers or anything else are implementation bugs. Like, implementing cryptography is really, really difficult and is easy to get wrong. And the problem is, like, a bug in a normal software means that and we're using Hangout, like, say there's a bug in Hangout, it means that, my headphones don't work properly. A bug in a cryptocurrency means that, possibly your money can get stolen, or there's a consensus failure, and or in cryptography, yeah. And those things are, and like Bitcoin, which is, as conservative as it possibly can get, had this double spend bug, which luckily they discovered in time, but which could have, allowed people to double spend coins without any fancy cryptography or whatsoever, And I think we need to be, like, having good cryptographic implementations. That's sort of where we need, a lot of eyes, a lot of, like, vigilance, and that's sort of, for me, the most scary part is actually implementing these things. So yeah.
Do you think Monero did a good job in the way it went about implementing bulletproofs? Is it up to par with the Bitcoin community?
I think that I think they did a good job in doing an audit. I mainly went over. Like, it's important to clarify what, like, I did part of the audit. I mainly went over to make sure that they implemented the correct math, and I pointed out the sort of the things that they got slightly off. But it was, like, smaller errors, nothing that could have caused a great break. And I think they had professional security firms also audit the actual implementation, not just sort of like, I just looked at the, from math to code, and then someone, to other companies looked at, is there sort of, I don't know, memory leaks or, whatever. I don't know what exactly they look at. So I think, these audits are they're not, like, obviously this doesn't give you can't get 100% guarantee. Like, it's just impossible. But I think that seems to be sort of the best thing you can do. And I think, one thing that the whole community does great is being open source, right? I would not trust a non-open source cryptocurrency. Like, that just doesn't make any sense whatsoever, right? And so I think that's what the whole community does. But I think these audits are good. Another thing that you can do is bug bounties, and I think in general, like, this sense of, I think what we've seen happen is with Bitcoin and Bitcoin Cash, for example, which are rivaling cryptocurrencies, where I think developers from the opposing, like, teams or whatever notified the other team that there was a bug in their implementation. So I think, that, like, we have to have, I think it's good that, like, to remember that it's not, people like to pivot these cryptocurrencies against each other and, say, like, Monero versus Zcash, Bitcoin versus Bitcoin Cash, or whatever. And you, like, for whatever reasons, they may be good or not. Like, I think it's important that, to sort of remember that, in the end, they all have very similar motives and are sort of striving for similar goals. And that I think this sort of larger sense of community enables, people to not say, okay, I'm just going to, I found a bug in this other cryptocurrency, which I don't, I'm not a fan of, I'm just going to exploit it, but rather to say, like, hey, I'm going to have a responsible disclosure and tell the developers to fix this bug before it becomes an issue. So I think that's an important thing. And yeah, the other thing is that you shouldn't, like, in terms of cryptography, you shouldn't, like, it's important to use cryptography, I think, that comes from academic reviewed papers, that it also doesn't, that's not a guarantee, but, like, you shouldn't just invent your own cryptography and just use it. But, like, if you do, or, then submit it to an academic conference, there's this whole process, and ask for reviews and ask cryptographers for reviews, and like, see whether the things that you're doing, that you're, even if it's just a small change, like, just see whether that's, like, get more eyes on it. In general, sort of more eyes are better. So, but in general, I think, the audits were a very, very good idea.
So just trying to understand the space better. So, Bitcoin, whatever, invented in 2009. Satoshi at that time, basically, in terms of cryptography, he just kind of took what was already existing off the shelf, correct? There was no really advent in cryptography with the development of the Satoshi.
It's quite interesting that Bitcoin uses very simple cryptography in some ways, like signatures and hashes, which, like, it might seem fancy on the outside, but it's actually not. It's not particularly. The design is still very it's genius, right? And it's a really cool design, but it's actually quite impressive. It's even more impressive that he was able to do this with such limited cryptography. And then I think, Monero and later Zcash use sort of fancier cryptography, and we've seen that sort of coming more and more, like, more and more fancy cryptography coming in, and then also, like, people developing new cryptography specifically with cryptocurrency applications in mind.
So is the blockchain space funding cryptography development in any way, or not directly in any way that you know of? It's really just coming through the university funding.
No, there are. I mean, that's that's one of the great things. I mean, personally, so we have the Center for Blockchain Research at Stanford, cbr.stanford.edu, which is funded by several cryptocurrency sponsors, foundations, and I think that this is funding a lot of the not just, the cool thing is that it's not just funding cryptographers, but also I think the need is like, I think funding cryptographers is very important, and I think this is happening more and more, and it's actually great that I think it's amazing that people are acknowledging the impact of research and are sort of funneling money back and are funding that. But it's also the whole idea of the Center for Blockchain Research is to get other parts of academia involved. So there's a law professor there. There's a professor in economics or game theory, that is part of the Center for Blockchain Research. There's someone working on programming languages, on verification and all of these things. And I think that on consensus. So the cool thing about blockchains is that cryptography is a part of it, but one thing that I really find exciting about it is it really connects so many different areas. There's consensus, there's cryptography, there's finance, there's social questions of and things that I'm in no way an expert in, but it's the cool thing is that really you have to have some sort of understanding of all of it. Or it helps to have some understanding of all of it, and I think that's makes it a really exciting field.
So who are the types of people that are backing? These are like VC firms, like the same type of guys that are backing the Coinbases of the world, or?
I mean, I can read to you the sponsors. It's not not private. It's the Ethereum Foundation, Protocol Labs, Interchain Foundation, Omis Go, Dfinity, and Polychain. I guess Polychain is VC. I'm sure of the Monero Foundation. I'm not, we gotta get
Monero on there.
Great. So I'm not. I think that I think that also there's other universities that get funded through other means, and this is just specific to Stanford, and I think that. I think Monero has. I know that Monero Research has started talking about or has issued, grants, and I think that's I think that's really important and a really cool thing to do. And I think that for young professors and young PhD students in the field who don't have funding, this can be really important. And I think that's a great way to. And I hope that I don't know, maybe one day I'll be a professor, and I hope that I can get funding through cryptocurrencies and whatever. That's but we'll see. This
it's really unbelievable because it's kind of like it's bootstrapping research in cryptography in a way that I imagine has never happened before.
Definitely not. And sort of the speed at which things moves is new, and it's really exciting, and I think that's definitely one of the sort of whole prize bonanza and volatility has its benefits and downsides. You get it certainly creates a lot of noise as well, which makes it you always have to ask people for sort of what their true motivations are. Are they just motivated by financial gains, which isn't something inherently evil, but it sort of makes things sometimes a little bit more difficult, but it certainly also has positive effects, and I think this is one of them.
So you mentioned one of the holy grails being a non-trusted setup for something like ZK snarks, right? I always get mixed up between the two. So what are some of the other major things that researchers in cryptography are working on right now? What are like some of the big problems?
I don't know what the big problems. I mean, there's people are working a lot on as I said, quantum secure cryptography is always a big thing. People are working on things that have probably to do with this field called obfuscation, which people are working on. I think I can tell you some of the stuff that we've been working on, like personally. So one thing that we've been working on is so-called verifiable delay functions, which is the interesting. It's a function that takes a long time to compute. So say an hour or whatever. And the interesting thing is that it takes a long time to compute, no matter whether you have an ASIC or whether you are Amazon and have many parallel computers, or whether you have a single computer. And the reason is because it's a sequential function. So you only need one or a couple cores to compute it. But once you computed it, you can give a very efficient proof that you computed it correctly. So I can very efficiently check that this whole gigantic function was computed correctly. So why is something like this useful? Well, one of the applications that we had for it, or our original motivation, is that say you want to get randomness, say you want to run a lottery, okay? And for, I don't know, use green cards or for whatever, for electing a leader in a blockchain. What you can do is you take you take a block header from, say, the Monero blockchain, and the block header, because it's created by proof of work, the solution to the proof of work looks random, right? It sort of looks, or it's hard to predict what that's going to be. The problem is if you just take that, say we take the next block, and then if the proof of work solution ends in or if there's more zeros than ones, then it's heads, and if there's more ones than zeros, then it's tails. And we'll do a coin flip on that, for $1 million or whatever. So the problem with that is that you can go to the miners and bribe them and tell them, whenever it's tails, do not publish the block. Right? So you can bias the thing, and then hopefully through that you have a more than 50% chance of winning. So where does the verifiable delay function come in? Well, what we can do is we can take the block header and then compute a 1 hour long delay on it. And then the idea is that the poor attacking miner, he doesn't know whether, or you don't know whether this block header is heads or tails, because you don't know you can't compute this verifiable delay function fast enough. So you don't know whether to throw away the block or not. And if you just keep it to yourself and don't publish it, then you will lose the block reward, because the blockchain will have moved on. There's a block like roughly every 10 minutes. So you can use this to generate randomness from blockchains, which has many applications, and people are now using this to construct sort of more energy, like more greener, for example, to combine proof of space and these things to create something that has similar properties to proof of work, but without without burning as much energy, right? Because there's good arguments for proof of work, but I don't think anybody likes that we're wasting so much energy on it, and I know that the energy is important for security, but maybe we can have something where we can have similar properties, but without wasting as much energy. And these verifiable delay functions can help with that.
So you would still, in a proof of work arena, you would still have proof of work, but there wouldn't be so much that race to use more and more energy.
Also, the idea is you would use proof of space. So you prove that you've allocated a certain amount of space, and then you basically run like you basically allocate you fill your hard drive with lottery tickets, okay? And then you get in some sorry. You get in some random value, and that paired with your, or you get a drawing from the lottery tickets system, and then you take the best lottery ticket, and that determines basically how much time you need to spend on the proof of time. And the VDF is basically a proof of time. So you prove that you've then spent that many minutes to do the proof of time. And the first person, so the person with the lowest number on their lottery ticket, would probably be the one that wins the proof of time, okay? But the important property of the VDF is that it doesn't help you. You cannot really compute it faster by spending more energy on it. It's not like a proof of work where the more energy you spend on it, the faster you will be in solving it in expectation. But here it basically, like, there's sort of a gap to how much energy you can use on it. So, and the proof of space just means you have to allocate space. You don't have to waste, you don't have to burn coal to do that. It's just sort of a one-time allocation. It's still a resource that you have some opportunity cost for. You would like to use it for storing all your favorite movies. But so the idea is that now, because the proof of space doesn't take time, it doesn't take energy, and the proof of time also takes limited energy. Now we don't have this race anymore, this energy race anymore. The only race that you have is to use sort of more space, because then you will, you will have, this will make it more. This will create more. You have a higher probability of winning. So, and this can also be used in other ways, but I think maybe this can help to get us closer to sort of something that has similar properties to proof of work, but without having to waste as much energy, which I think is something important.
In terms of proof of work itself, and Monero and how it's been trying to, I guess, eliminate ASICs, do you have any opinion on that, or?
Yeah, I mean, I think
we hard forked again away from ASICs by changing.
Yeah, I've been like sort of following that. It's it's not. I don't have a strong opinion on it, but I'm not quite sure that sort of phasing out ASICs is the best thing. Like, it's inherently a good thing. Like, I can see the motivation for it. The problem is, like, if you think about it sort of from a purely economical or like incentives point of view, if I have an ASIC, if I have a Bitcoin ASIC, I cannot use that for anything else, right? Like, it's completely impossible to use my ASIC for anything else, because it's like the most specialized stupid machine, whatever. So I don't really say I have 51% of the mining power. Will I really attack Bitcoin? Because what would that mean? It would mean that probably the price of Bitcoin would drop significantly. So all this expensive hardware that I bought will suddenly become useless. So, what have we seen in the past is that there's been, I think there was like ghash.io way back in the day had actually 51% in the day. And they actively shut down machines to get below 50%. Just to assure the community, hey, we're not going to attack Bitcoin, And we've seen very little attacks, even though they're sort of academically feasible. And I think part of the reason is because of this buy-in, and because of this because miners really pay their utility bills in dollars or in fiat currencies. So they care about the value of Bitcoin in a fiat currency very much. However, if you have like say you have your perfect, ASIC resistance proof of work, you can run it on like Intel CPUs or whatever, your CPUs, just as fast as anything else. Like, specialized hardware doesn't help, or GPUs or whatever. Well, the problem is then I can attack, I can attack Monero, sort of do a double spend, get some money through that, and then I can use my mining chips, so my hardware, I can just use them for doing whatever, right? Like for playing computer games if it's GPUs, or for, they still have a value. So it's less of this buy-in effect, and sort of in a similar way, I can just rent resources from Amazon for a short amount of time to do an attack. And there's this notion of a gold finger attack, where if I'm able to bet on the price, so if I'm able to bet on a falling price, then maybe all I want to do is screw up the system. Like I attack Monero just to screw up the system, and get some reward from this outside bet. And if that's not too expensive, then this becomes really dangerous. And I think there's I see the value of I think the whole notion of ASIC resistance is for sort of a democratization of proof of work. And of course, it's like that the miners in Bitcoin are like 8 people and 8 different entities in China, and we don't even know if it's really 8 or if they are secretly colluding. Of course, that's super scary, and I don't think anyone likes that. But it's not as clear cut to me as some people make it seem.
Yeah, I think one of the strategies that's being discussed is to kind of ward off ASICs until we don't have to anymore. So kind of temporarily try to hard fork away from them for whatever the next X amount of years until ASICs are there's no longer a few guys that have the advantage where only they can produce ASICs. So kind of where it gets to the point where anybody can easily get in the ASIC game.
Yeah, I mean,
one of the strategies. I think it's
maybe your future CPUs will have a coprocessor that's sort of an ASIC and whatever. I mean, I think that's that would be that would be a cool future. Like, as I said, I don't, it's not a clear-cut thing to me. I would just say that it's not like that. It's exactly that, not a clear-cut thing. So that there are advantages to mining pools as well.
Mm-hmm. So do you think Monero is currently the most like fungible and private crypto we have?
I don't know. I mean, it's like, I think that sort of, if you just look at the technical properties, like Zcash has the advantage that you're basically, every time you're spending a coin, you're saying I'm spending one of the old coins, so one out of all of the coins in the whole history. I'm not saying, it's like in Monero you say basically I'm spending one out of these 10 coins. And in Zcash, you're saying I'm spending one out of all of the coins. So that technically is, of course, better. The thing, though, is that, like, no one uses Zcash transparent, like these addresses. So the anonymity set is really, really bad, and that, like, actually really matters. And I think there's been even papers showing that, even with that level of privacy, you can detect things and you can figure out things, and like, because the privacy is so, like, the anonymity set is so small, it's actually not very good. So I don't want to. So I think there's a trade-off. I think that Monero is used by a lot more people in sort of real-world scenarios. So that gives you a much better anonymity set in that. But like, technically, from the properties that just the pure statement, it's sort of the Zcash statement gives you more privacy. But it's also like it has the downside of having the trusted setup, right? Like, you have to trust this trusted setup, and I think it's also like it's a difference in governance structure. Zcash is a company, and Monero is more run by a community, which has different pros and cons. Like, I think my personal opinion is that it's good that both of them exist. Like, and I think it's a competition is healthy and beneficial, and I think that it's very, very good that both of them exist and can compete, and can push each other to be to not get lazy and improve on whatever properties they have.
How about Grin or Mimblewimble and Grin? Are you excited about that? Are you looking at that?
Yeah, I think there's Mimblewimble has like two different teams are doing implementations, Grin and Beam. I mean, like the thing that you don't have in Grin or Beam is that I think it's certainly very interesting. I think the thing that you don't have in Grin or Beam is that you don't have like you can't hide as easily who's paying whom. You need to do sort of it's more like basically like confidential transactions. It's like Bitcoin with confidential transactions and default mixing. Like in Bitcoin, you can do this mixing, and mixing becomes a lot better once you have confidential transactions. So the idea is that I have a transaction with many inputs and many outputs, and if I don't know, and sort of it's hard to track which input goes to which output, and in Grin, this means that so once I have, the problem is in Bitcoin, this doesn't really work because say one input is 0.7345 and the other one is 1, and then you have one output that is 0.7345 and the other one is 1, then it's very easy to map what maps to what. In something where you have confidential transactions, this mixing becomes a lot better because all of the inputs are just these cryptographic hiding commitments. But the big difference is that in Monero, and Zcash, I can say like, I am one of these, 10 inputs, and I don't need the consent of the 9 other parties, or in Zcash, I don't need any consent. And in Grin, I need to sort of work together. I need to find 9 other parties and communicate with them and create a single transaction to get sort of that anonymity set. So there is sort of the one is, in one I have to communicate and interact, and the other one I don't. So, I mean, I'm excited about anything that uses my research, and it seems like both implementations will use Bulletproofs. So obviously I'm very excited about that. But again, I don't think that it's clearly better or worse than Monero or Zcash, and I think more competition is good. And I think it's also like a very simplified design, right? You can't have scripts, you can't. It's a very it's quite elegant in that it's a very stripped down design, but obviously sort of this elegance and this stripping down of not being able to do scripts or fancy things reduces the reduces the functionality, I guess.
How about regulation? Do you have any opinions on that and how regulation might affect privacy coins, or do you have any opinion on regulation in cryptography? And I mean, obviously I would think it would be that cryptography itself should never be regulated.
Oh no, yeah. I mean,
so at what point?
There's been, we've had this history of the so-called crypto wars, where this is before my time, and before I was like even remotely involved in cryptography. But the idea was that the U.S. government, I think, outlawed exporting to cryptography. So exporting algorithms, which is just sort of crazy in itself, and let the rest of the world use sort of worse cryptography, such that the NSA can break, or the CIA can break, their cryptography. That obviously seems like a terrible thing, and luckily there was a Supreme Court ruling, I think, that overruled this and made this illegal. I think what's very scary is that a lot of politicians, actually more in Europe now, are talking about inserting backdoors into like things like WhatsApp. Whenever there's a terrorist attack, and the terrorist use WhatsApp. Like, surprise, surprise, you know, everybody in Europe uses WhatsApp, or use iMessage, you know, that's like, then they say like, oh, you know, we need to be able to read, you know, what they write, and you know, this would let them sort of be able, read what everybody writes, and I think that gets pretty dystopian quite like quickly. So, you know, obviously I'm an opponent of that. I think that, yeah, you know, regulating privacy coins, I hope that, you know, there can be a reasonable, some sort of, you know, reasonable ground means, you know, I think that like people can hopefully find a reasonable solution. I don't think I have you know, I know what to do there. I think that one interesting thing in cryptocurrencies in general, or decentralized cryptocurrencies, I like to like differentiate between, like, say, the decentralization aspect and cryptocurrencies, because you can totally build a cryptocurrency that is completely centralized. And like, there's some value to it, right? Like, you could have a centralized, like, Fed regulated system where you have anonymous, like, Monero style transfers. So the Fed couldn't see how much is being transferred, but they could censor transactions, which, you know, has certain downsides, but like is at the very least, you know, it could be dollar denominated. Like, they could have a crypto dollar with anonymous transactions. But the decentralized aspect of it, I think, has one important property, which is that, like, the reason why banks are so heavily regulated and need to be heavily regulated is because they have your money, right? You know, if they want to, they can do whatever they want with it, and you know, they lend it out to other people, and you know, if they don't do that properly, then you will never see your money back. A miner does not need the same regulation because it's sort of ensured by the rules of the system that the maximum damage she can do is limited. So this whole aspect of decentralization is, I think, like, one major benefit of decentralization is that parties do not, you know, the network operators, which are the miners in this case, do not need to be heavily regulated because they're not monopolies. It's not like Facebook is a network. Facebook is a network operator and is a monopoly, and we've seen sort of in recent times that this can lead to bad effects. You know, if they don't take care of your private data, then things go bad. If, you know, they give all your data to Cambridge Analytica, then that's a problem. And the good thing is that in a cryptocurrency, like the miners can't do that, and they can't just decide to, you know, like, if it was a central party, then they could, you know, print money, censor transactions, whatever. But if it like works decentralized, then they can't do that. So I think, you know, I hope that we can convince regulators that, you know, these cryptocurrencies need to be regulated in a fundamentally different way from traditional financial systems.
That's interesting. Yeah, I've always looked at decentralization as being a means for, you know, creating censorship resistance, and I never really saw this other use for it, which obviously makes a lot of sense.
I think it's, you know, people throw around decentralization as something that is sort of inherently good, and I think we need to be careful with that. I honestly don't think that's true. Like, I think you need to be able to clearly articulate why decentralization is good. So, for example, you know, like, a centralized system can be infinitely more efficient, like, than a decentralized system, right? Mm-hmm. Because, you know, it's just like one guy, you know, one database that checks, you know, is everything okay? Is it in the database? Is it not in the database? Perfect. You know, we have great, like, you know, Google is a great decentralized system that works really well. The problem is in a network, you know, we have these network effects where the more people are added to the network, the more the value of the network grows. So it's beneficial for me to join a network that already has many users, right? I think that the problem, though, is in a network, the network operator, the person that has control of the network, like, gains a lot of power because of that. if I wanted to make a new credit card network, I would have a very hard time and no one would use it, even if my fees were 0 or infinitely lower than Visa's. Why is that? Because Visa is accepted all around the world, and it's really, really convenient because every shop and everything in the world is. However, this gives Visa a monopoly power, which means they're sort of, they have less motivation to innovate and they can charge whatever monopoly fees they want. And like sort of, minus MasterCard, there's a duopoly, or, there's American Express as well. But like there's very few operators, it's an oligopoly basically. And I think that the nice thing is, even if, a single cryptocurrency were to exist and were to be globally used, then the fees could still not be infinite, because there would be competition among the miners who will accept the transaction, right? If one miner doesn't accept the transaction for, because he wants to push up the fees, well, then the next one will. He will be happy to take the fees, right? So you have sort of a network, but without the monopoly operator. So that's sort of my view on a decentralized network. But I think in other scenarios, it's not. It's not like everything decentralized is better. That's just not true.
Do you think Monero is doing a better job than Bitcoin at maintaining? I know we talked about this a little before, but at maintaining its decentralized nature?
I haven't, like,
it's hard to quantify.
I don't know. It's like they are defining sort of the decentralized nature is difficult, but yeah.
What do you think of ring signatures? I mean, that's another thing that took place today in our hard fork. We, I guess increased the decoys, I think, whatever it is, from 7 to 11. I'm not sure if that's correct, but we upped that number. What do you think of ring signatures in general, and whether or not is that something that Monero is kind of stuck with, or will we eventually maybe replace that function as well with something better?
I mean, a ring signature is basically just another zero knowledge proof, right? It's like I know that the term ring signature sort of gets used for it, but it's just another zero knowledge proof. It's a proof that I know, one of the secret keys to one of these coins that I'm spending. And I think that increasing the anonymity set is important, and I think there's been research showing that if the anonymity set is too small, you can very easily sort of de-anonymize things. So I think that's generally a good thing. I'm sure though also that that sort of the efficiency of the ring signature. I haven't actually spent too much time looking at it, but I'm sure that the efficiency of it could be improved. So
how do we get you to start doing that?
I think that's actually, there's been a lot of research on that, and I think on ring signatures, and but I think the other thing, in essence, what Zcash does is just a gigantic ring signature over everyone. So that's certainly something that you could maybe move to in the future, right? Without, like, that would probably not be using snarks, but using bulletproofs, which is not. It's totally possible that you can sort of instantiate, like, there's a lot of implementation questions, but it's not impossible. And the concrete numbers matter a lot, but like that you can instantiate something like the zero cash scheme with bulletproofs. So you would get, the same anonymity guarantees as zero cash, but without the trusted setup, and on Monero system. So I think that's something that could be interesting as a future development.
That's awesome. So did you use Monero today? Did you try it out, zap it around?
I have not. I should. Yeah, I'll probably do that. It's pretty cool,
Yeah, there's a lot of excitement. I think so. I think the transaction fees dropped to about 0.5 cent today.
Yeah,
which
I
is
mean, you know, like for me personally, you know, this is amazing. You know, like I would have never, you know, guessed this. You know, that like my research could be, or our research could be, you know, securing like that much money and you know is deployed within a year in a live system, and yeah, it's just really amazing. And yeah, I'll definitely try that out. You know, send a Zcash transaction, send a Monero transaction. Sorry.
maybe throw up a donation link on Reddit and we'll test it out. We'll
Yeah.
send you some Moneros. Well, thanks
Sounds
again.
good.
Actually, what do you think of the dynamic block size? That's the one last thing I wanted to ask you about. If you had any thoughts on that.
Not too many, to be honest. So I honestly don't even know what the rules are. I think that, you know, it's honestly just don't know. Like I think that, you know, it seems like something reasonable on the first, you know, but I haven't sort of closely looked at it.
Okay. All right. Well, I really appreciate you taking the time. Really excited about the developments. You must be ecstatic to actually see, like you're saying, to see your hard work actually being implemented.
Yeah.
And just thank you again. Thank you for all your contributions and taking the time.
It's important that, you know, it's by no means just my work. You know, it's my co-authors and like even more so also, you know, all the people that implemented it and you know developed this and pushed this through, and you know the community. So I think, you know, it's great.
Thanks again.
Cool. Bye.
All right. Thank you.